structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science, and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology, and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of health and the treatment of disease. Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations under full field conditions. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Ukulinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Westville campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Center showcases the college's scientific achievements and promotes the public understanding of science, engineering, and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. College has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centers within the college. The African Center for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Center for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Center for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centers at the university, the Center for Plant Growth and Development focuses on high-quality research in the plant-based disciplines of plant physiology, plant molecular biology, and ethnobotany. The Center for Quantum Technology deals with physical phenomena at the microscopic level. Quantum physics led to the development of
a warm good morning to all of you from the University of KwaZulu-Natal, Durban and Peter Marisburg campus. On behalf of the Deputy Vice Chancellor, Professor Albert Modi, the College Dean of Teaching and Learning, Professor Naveen Chetty, who conceived this idea and took this initiative to run the helpline, and Mr. Ashwin Manival, the convener of this Matric and Grade 11 helpline sessions, it is my greatest pleasure to welcome you all to the first session today morning. Students, my name is Dr. Bobby Varghese, and I am the head of the Teaching and Learning Center, which runs the Science and the Engineering Access Program in the college. I'm sure that you have seen the dates and times for various revision sessions. And these sessions in mathematics, physics, chemistry, and life sciences run by our college are being held with only one purpose in mind, and that is to help you to improve your achievement, to achieve excellent marks in the forthcoming metric examinations. So University of KwaZulu-Natal could be your university of choice. We are the 3rd best university in South Africa and one of the top 10 universities in Africa. UKZN is in the top 400 universities in the world with a rich heritage, more than 100-year-old, 120-year-old university, famous alumni who have passed out of the university. We really look forward to welcoming you to a degree of your choice next year. But for now, let's focus on the sessions. Just a quick reminder that there is stage 4 load shedding across the country. You may know about it. So if you have issues with network and load shedding, and if we may have issues with network and load shedding, my humble apologies in advance. Please let me remind you also to stick to Zoom etiquettes. Keep your microphone on mute all the time. If possible, put your videos off so that we do not play on the bandwidth. And put your questions on the chat and we will get back to you. There are competent lecturers who will be leading these sessions. We have tutors who will be also helping out the students in this session. So please put your questions in the chat. If you have any further questions from this session, or even while you're studying at home, you have doubts, so please do not forget to send email to our mathematics helpline or physics or chemistry or life science helpline email addresses, which is also there in the brochure. You can get those email addresses. We will also put those addresses in the chat once again and before the end of today's session as well. And in the chat, we will also inform you the date and the time of the next session. Let me remind you, today at 1 p.m., Today at 1 p.m. we have the chemistry session, and at 5 p.m. later in the evening today we have the physics session for revisions for metric. You would like to know that tomorrow on Saturday as well we have sessions, so we will inform you about that. So let me not take much time. Thank you for joining us. I hope you'll have a great experience and a learning experience. Get ready for the sessions and enjoy the sessions. So on behalf of the College of AES, once again, a warm welcome to you all. And let me hand you over to the lecturers for today. Thank you. Ashwin, you can ask Shan to start, please.
Good day, Shan. If you're on, you can begin your section.
Okay. I am trying to open a document by shared screen. Let's see, share. Call me Reshanya. What's the stop sharing? I want to share this document there.
Yeah, it's which doc?
That one there?
Yeah.
Okay. Good morning, everyone. Thanks very much to Dr. Bobby Varghese, Professor Naven, my immediate line of communication, Ashwin, Dalia, and others in the team. This morning, I'm going to discuss problem solving with the aid of a few examples. Now, problem solving is extremely important in mathematics. It enables students to develop academic skills, which are important to be successful in your studies at a university, in choosing careers, etc. It requires logical reasoning rather than a memorization of data, formula, etc. What is the meaning of thinking out of the box? It also involves new ways of doing mathematics and include the use of technology. Finally, when you find an answer to a solution, you must be able to check your answers, and we'll teach you some strategies how you can go about doing this. Now, especially to the students, please have a pen and paper handy. I would like this session to be interactive. As mentioned earlier, if you have any queries, you can post them, so we will have a look at them and get back to you. The purpose of this session is for you to do a few problem-solving examples, and we can discuss the strategies and the ways that is included, that is involved in these. So here's the exercise. Question 1. Jack and Jill have the same number of coins. Jack has 100 20-cent coins, while Jill has 60. So I change that to 20-cent coins. So basically, we know that Jack has 100 20-cent coins, Jill has 60 20-cent coins. Who has the greater amount of money? Now, the first step in problem solving is to read the question. You may have to read it more than once to understand the question. Then let's analyze it and find a way of solving this problem. How would you attack this problem? What strategy you will use? Okay, so we have Jack and Jill have the same number of coins. That is an important fact. Same number of coins. I've just highlighted it there for now. Now Jack has 100 20-cent coins. Jill has 60 20-cent coins. Can we, at this point, make an assumption that who has the greater amount of money? Now, there's two facts there. If both of them have the same number of coins, but Jack has 100 20-cent coins and Jill has 60 20-cent coins, therefore we can assume that Jill has more 50-cent coin, because you put all that together, the numbers are the same. Okay, so now we need to find a way of tackling this problem. Now you cannot use a linear equation or quadratic equation that you have learned, but keep that in mind. They are tools that will come in handy some other time.
Okay.
Now, my method of solving this is to draw a table. Okay, so the facts: Jill has 100, Jack has 100, 120-cent coins. I've constructed a table. I've got the columns: 20-cent column, 50-cent column, and the total. So Jack has 120-cent coins, but we don't know at this point from reading the question the number of 50-cent coins. And as your teachers would have taught you, if you don't know something, it's a variable, you can call it X as a starting point. So if Jack has 100 20-cent coins and X 50-cent coins, therefore the total must be 100 plus X. Now, I highlighted earlier on that they have the same number of coins. So column 4 will be 100 plus X and 100 plus X for both Jack and Jill, because they have the same number of coins. But the difference in their money is they have different amounts of number of 20-cent and 50-cent coins. We will try to work that out. So Jill must have 60, she has already at 60 20-cent coins. So it is logical that she has another 40 50-cent coins. So that gives you a total of 100 plus X. Now, Jack has 100 20-cent coins. What is 100 equal to? 60 plus 40. So now we can match the numbers and tally them up in this table. What do you notice? If you notice something in the table and you try to match each component there, we can see that Jill has 40 50-cent coins. And what about Jack? Jack has 40 20-cent coins. Isn't that the only difference? Okay. We look at the last column again, totals. The numbers are the same, 100 plus X. In the 50-cent coins, Jack has X, but Jill has 40 plus X. In the 20-cent coin, Jack has 40 20-cent coins. So that is the difference. All the others match. So it's clear that Jill has more money because it's 40 extra 50-cent coins, which is 20 rands. And Jill has 40 20-cent coins, which is 8 rand. Therefore, Jill has 12 rand more money than Jack. Well, that's your answer. Now, the strategy I used here was to draw a table, fill in the data, match those that are equal, compare that those that are unequal, that is 40 50-cent coin is greater than 40 20-cent coin, and the amount is 12 rand. So that's your answer for the first question. The strategy I used was to draw a table. Now remember, in mathematics, every example does not involve solving equations or using formulas, because in undergrad maths, you have we have sections called logic, proof techniques, etc. There you have to read. You got to devise your own way. You got to use logical reasoning. Okay, I will go on to question 2. By the way, I'm sharing my experience.
Sorry, sir.
Yeah.
May you please go back to question 1?
Okay. No problem.
So if I may ask, is this still math?
Sorry?
Sorry, sir, to the question.
Yes, what is the question?
Oh, can you scroll up to the question?
Okay, sorry. Yes.
So if I may ask, is this still bad?
Do you want me to read the question?
Sir, can you check your chats? Because everyone is asking questions there.
Look, I appreciate your questions. Can I do the 4 examples, and then we can set aside some time to look at your questions? Will that be okay?
That's fine, sir.
Because I'm sorry. Look, I'm only discussing 4 examples, and at the end of the session, a
Confusing
little
is
bit.
that we want to know if this
Sorry,
is still math. We want to know
if
if
this is
this is still math.
Sorry, sir, they're asking if it's math or mathlet.
yes, this is part of maths. Yes, okay. As I said, I'm sharing this. The problem solving is going to help you prepare you for the university. Your studies at university is very important. There are metric paper 1 questions and answers. There will be sufficient attention paid to that. So I'm just going to spend another half an hour with these examples, which are important. All right. Can I go on? I'm going to go on to the second example. Solve the equation 2 to the x equal to 2 times x. You can get an example like this in your exam. Yeah, I agree with you. It's not the type of question that are in the question papers. But this is an equation. How would you solve this one? Okay, 2 to the x equal to 2 to the power x is equal to 2 times x. Right. This is exponential. An exponential term, and 2 times x is a linear term if I'm relating this to graphs. You're allowed to guess and check, and it's also trial and error. For x equal to 0, 1, 2, and 3, we can substitute and check. Let's try 0. 2 to the power 0 is 1. On the right-hand side, 2 times 0 is 0. 2 to the power 0 is 1. And 2 to the 2 times x is 0. So 1 is not equal to 0, so 0 is not a solution. Let's try x equal to 1. 2 to the power 1 is 2. 2 times 1 is 2. So the left-hand side is equal to the right-hand side. Therefore, 1 is a solution. Let's try x equal to 2. 2 to the power 2 is 2. 2 times 2 is, 2 to the power 2 is 2 times 2, which is 4. And 2x is 2 times 2, which is 4. Therefore, x is also equal to 2. Let's try 3. 2 to the power 3 is 2 times 2 times 2, which is 8. And on the right-hand side, you got 2 times 3, which is 6. Now, 8 is not equal to 6. Therefore, 3 is not a solution. What about x equal to, say, minus 1? If you try minus 1, 2 to the minus 1, as you know, it's 1 over 2, which is half. But on the right-hand side, you get 2 times minus 1, which is minus 2. So if x is negative, on the right-hand side, you have negative outputs. On the left-hand side, 2 to the minus 1 is 1 over 2. 2 to the minus 2 is 1 over 4, etc. So x cannot be 0, it cannot be negative. So x is equal to 1 and 2. Now, are there, the critical question is, are there any other answers? How can we justify this? Now, what we can do is look at the 2 parts, the left-hand side and right-hand side. Let f of x equal to 2 to the power x. And as you know, it's exponential function. And g of x equal to 2 times x. Right. We can draw the graphs. I'm sure all of you have experience drawing the exponential graph, straight line. And let's see where they cut each other. Okay, there's a graph. The graph f of x equal 2 to the power x, it's exponential function. It cuts the y-axis at 0, 1. And there's a straight line passing through 0, 0, y equal to 2 times x. And you'll find that both graphs cut each other twice only. Now, drawing the graphs are important, but understanding the graphs, interpreting the graphs, the points of intersection, and other things like maxima, minima are also important. So x equal to 1 and x equal to 2. So by drawing the graph, you're justifying your answer. Okay, now I'm going to go on to question 3. Now this is a very simple problem. ABCD is a square with points P and Q, midpoints on AB and AD respectively. What fraction of the area of the square is covered by the triangle CPQ? Right, you can just read it one more time and try to work this out. Now, also I may remind you that these are word problems, and when you studied calculus, at the end of calculus, you were given questions on maxima and minima. There you have to read, draw diagrams, and try to answer the question. You may have recalled the question: the farmer constructs a rectangular enclosure on the next to the river bank and uses fencing to maximize the area. Well, these are problems, so it's an important exercise to read, understand, draw diagrams, and to solve. And I'm emphasizing this again, that it will help you in your studies at the university. Right, let's look at the diagram. Okay, now ABCD is a square there, and I've shaded the triangle CPQ. We want to know what fraction of the square is shaded. We may be tempted to say that the answer may be half, but we need to work this out. Right, the square is given, P and Q are midpoints, and triangle CPQ is shaded. Now, how would you work this out? Now, you were taught that the area of a triangle is half base times height. Also, using trigonometry, half AB sine C, etc. And if you look at the internet, there's another formula which is called Heron's formula. Now, I'm posing this question so that we can think outside the box, so to speak. I'm going to let the side of the square equal to 2 centimeters. So if BC equal to 2 centimeters, that's the side of the square, then DC is also equal to 2 centimeters. Since P is the midpoint, AP is 1, PB is 1, AQ is 1, and DQ is 1. Now, what we can do is find the area of the triangles that are unshaded. That is CBQ, ABQ, and CDQ. That's very easy to work out. Now, if you take that out, you'll be left with the area of the triangle. So notice we did not use, can we get some silence? I'm not sure what's going on there. Right, so the area of the triangle, CBQ, is half base times height. It's a right angle triangle. So the area of triangle CBQ is 1. And that is also equal to the area of triangle CDQ, which is half times 2 times 1. So that is also 1. But the area of triangle APQ is half times 1 times 1, which is half. So the three triangles have areas 1, 1, and half, which is 2.5. So the shaded region is 2.5 square centimeters. The total area is 2 times 2, which is 4. Now, when you simplify that, okay, the area of the triangle is the area of the square is 4 square centimeters. We take out the 1, take out the other one, and take out half. So in fact, you're left with 1.5, and the total area is 4. So what is 1.5 divided by 4? You multiply the numerator and denominator by 2, and that will give you 3 over 8.
Sorry, sir, where are you writing?
Okay. Where am I writing? Oh, you want to see the writing?
Yes.
Okay. All right. Sorry about that. Okay. Can you see the diagram, and do you agree that the area of triangle CBQ is 2 times, what is the area of triangle CBQ? Do you agree it's 1? The area of the triangle is half base times, right? So that's 2 times 1 times half. Yes, this example, I thought I will just discuss it with you, because from the diagram, we should be able to do these calculations quickly, but not a problem. Later on, I will write the answer out, and then you can have a look at it. Is that okay? Sorry about that. Right.
Yes, it is.
Okay, number 1, the total area, the area of the square is 2 times 2, which is 4. Right. Then I find the area of the three triangles, which is area of triangle CBP. The area of that triangle is half base times height. So that is 1. And similarly, the area of CDQ is also 1, because those two triangles are congruent. And the last triangle, APQ, is 1 times half, which is half. So the total area is 4. We subtract 1, 1, and the other triangle, which is half. So we are left with 1.5 divided by 4. And that simplifies to 3/8. Now, I did this deliberately so that we emphasize that quick calculations are also important. But as I said, I will write the answer out for you and you can have a look. Now, the last question, question 4. I need to scroll up. Students, please bear with me. I'm doing this for the first time using a shared screen using Zoom PowerPoint, the Zoom session. Question 4. Previously, I used to use Windows Journal and pen at the university, which was very easy. Well, we need to get used to new ways of doing things. This is quite popular. Right. Question 4. 12 is a 2-digit number. If the digits are reversed, we get 21. It means that if you have 12, by reversing the digits, you get 21. So 21 is greater than the original number 12. The question is, how many such numbers are there? And obviously, 2-digit numbers, the largest one is 99. So we want to find out how many such numbers are there. The procedure is take a 2-digit number like 12, interchange the digits, which becomes 21. 21 is greater than 12. Now we want to find out how many such numbers are there. Now, students, here there's no formula. So we're going to do it by trial and error. Okay. We start with 12, which becomes 21. So that satisfies the condition by reversing the digits. 21 is greater than 12. 15 becomes 51. So that is also true. So we need to find a strategy how to get all the possible numbers that satisfy the condition. Now, an interesting case is the numbers from 91 to 98, or even to 99. If you take 91 and you swap them, you get 19, which is smaller. Same for 92, 93, etc. Now, it is clear that there is no number from 90 to 99 that will satisfy the condition that's required. Now, I've chosen this example so we can try to determine a pattern. Let's try 81.
Sorry, Shan, there's a hand up. Sam has put his hand up.
Okay.
Sam, please go ahead.
Question? Can you unmute and so I can listen to the question?
Sam, you're unmuted. Can you please ask the question?
I'm not hearing the question.
It's fine, Shan. You can go ahead because the student is not asking.
Okay, sorry about that. But as I said, if they post the questions, we will attend to all the queries later. I just have another 10 minutes or so. Let's look at numbers from, okay, let's first understand the question. We take a 2-digit number and we reverse them. I gave you the example of 12. When I reverse the digits, take 12 becomes 21. So the condition is satisfied that by reversing the digits, the second number is greater than the original number. So that is what we are looking for, such numbers. Now, if you look at the numbers from 90 to 99, there is no such number. The purpose of this example is to find out, to look for a pattern. And looking for patterns are very important in maths and in daily life. I'm not going to go into details here. Okay, so we're looking at the numbers from 80 to 89. 81 becomes 18. So that's not satisfied. Similarly, 82 becomes 28. They are smaller. But if you look at 89, that becomes 98. And 98 is greater than 89. So that satisfies the given condition. So first we look at the numbers from 90 onwards. You had 0. In the 80s, you got 89 become 98, which satisfies the condition that the second number, by interchanging, is greater than the first. So in the 80s, you get 1. So can we see a pattern there? The pattern is, in the 90s, there are no such numbers. In the 80s, there is only one number. Therefore, we can conclude that in the 70s, there will be 2. In the interval of numbers from 60 onwards, there will be 3. In the 50s, you get 4. And so your answer is 1 plus 2 plus 3 plus 4 and up to 8. If you want a detailed solution, I will post it up later. But for now, remember at the outset I mentioned, these are academic skills which are important. Looking for patterns, drawing a table, using a graphical method. So we will try to enhance your skills, academic skills, so that it helps you at the university. Now the final answer is what is 1 plus 2 plus 3 plus 4 plus up to 8? Okay, maybe I can just write it down. 1 plus 2 plus 3 up to 8. Now you can do that manually or mentally. Now what type of sequence is this? This is an arithmetic sequence which has 8 terms, and you may recall the formula: n over 2 into a plus 1. N is 8, 8 over 2. The first term is 1, the last term is 8. So your answer is 36. Okay, so these are 4 questions which are illustrated so that you can use that to develop problem solving strategies. And example, the strategies are drawing a table, using a graphical approach, which is integrating the algebraic and the graphical. Solving the equation can be done graphically, which is, the graphs are very powerful tools. Have a good knowledge and practice of that. Well, sometimes we have to use logical reasoning to get answers, like the one on Jack and Jill. Thinking out of the box, I use the square, the triangle inscribed in the square to find the area without actually using the formula half base times height. And use of technology is very important. I'm going to go to the second example, where by drawing the two graphs, you find they intersect at points where x is 1 and y is x is 1 and x is 2. So that gives you the solutions without any working, showing the algebraic steps. Okay, I'm going to stop here and I'm going to look at your question, your queries, if I can address them in the next few minutes. And if not, I will write them and post them so that you can have a look at it. Can I ask Ashwin to help me here to look at the chat? Yes.
Shan, I will help you.
Yes, please. I'll appreciate that. How do I get to the chat question? We can just talk about it. Because I'm on the shared screen now. I'm doing this for the first time.
No problem.
What must I do?
Yeah.
Minimize this. Okay, we are here now.
If anybody wants to ask a question, please raise your hands. You can then unmute yourself and ask the question.
Thanks, Dalia. How do I check for questions that are posted on the chat?
You can click on chat, that will open up the chat. So there, I'm also going through the questions. If I see something, then I will.
Yes, yeah, please raise it, then we can talk about it. I'm glad we can do this because it's interactive. I don't have to, behave like a lecturer. We like to listen to the students' queries.
Okay, regarding the first question, there was a student who wrote, in the question 50 cents is not mentioned. How would we have known that Jack and Jill had 50 cents as well? It is only stated that they have 20 cents.
That's a very good question. Jack and Jill have 20 cents coins only. We don't know how many coins, how many 50-cent coins do they have. Now, we were taught, or you were taught, that if you don't know about something, then you call it X. That's a variable. But since X is a variable for Jack and Jill, it won't make a difference to the total amount. So let's say if X is 250 cents. So it'll be 200 for Jack and Jill. Okay, can we take another question?
Sam, can you please unmute yourself and ask the question?
Mine is on mute.
No, Sam, the student, Sam.
Oh, okay, the student, okay.
Yeah, he or she has put the hand up. So
no problem, we're welcome.
Unmute.
Please ask many questions. I have a few minutes. I'm very happy to take your question and respond.
Please unmute yourself and ask the question.
Sir, I was gonna ask, what's the next section are you gonna cover, sir?
Look, you are writing paper 1 next week. So my colleagues will start with the exam paper. We will cover at least 2 question papers, paper 1. Then we'll also do paper 2. The next session will be dedicated to questions from past exam papers. Now, I had a good reason for doing this because we may not have had the chance. So my colleague will start with paper 1 for the next hour. Is that okay?
Good morning, all members, all morning members.
Morning, Mohammed Randy. Rachel Garrett, to everyone. He's not sharing the screen anymore.
Is there anybody with a question? Please unmute yourself and ask the question.
Yeah, now it's question time.
So can you maybe do a question regarding calculus, sir? If we can maybe go through one in the papers.
Yes, you can. Look, students, I think you're a bit anxious now. Sorry about that. Paper 1 will be discussed entirely. I think we'll try and do at least 2 papers. It will be on Zoom sessions, and we'll try and put it up on this site. My colleague will start at 10 o'clock, and he will start with with paper 1. If you have a question on calculus, let me know. I can give you a rundown what you need to do, and then you can complete that.
All right, if there is no more questions, let's move on to the solution of the past exam papers. Thank you, Shan. Thank you very much for covering the first session.
Thanks, Dalia. Thanks for the opportunity. I just want to wish all the students the best. And remember, your first choice must be UKZN, because UKZN inspires greatness. Best of luck. We know you've been through a lot with the pandemic, but you are there determined to make the best of it. Best wishes from me and the team. Thank you.
Morning, all members. Good morning.
Brandon, you can take over from now.
Cool. Thank you. Let me share my screen, then we can get started. Sorry, Shan, please can you stop sharing, and then I can start? Okay, thank you. Hey everyone, welcome again. So I just put this up here so that you can see. This is the schedule for maths, chemistry, physics, and life science. So today is session 1, okay, and then we will have session 2 and session 3 later on. So the plan for today is to go through 2020 paper 1. Okay, so if you have any questions with regards to paper 1, please put it in the chat. And then I have someone that will go through it and try to answer that for you. And if you have any questions on what I'm doing currently, please just raise your hand and then I can attend to your problem. Okay, but if it's anything else, please just put it in the chat. Okay, so let's get started. Okay, so we've got the 2020 paper 1 here. The reason I'm doing the 2020 paper, I'm not sure if you've noticed this from previous years, but a lot of the questions are repeated from year to year. And if they're not repeated like exactly, they are very similar. So if you can handle this paper, then you should be pretty fine for the next one. Okay, let's get started with question 1. So as with all the papers, question 1 is on algebra. So, you know, solving for x, simultaneous, and so on. Okay, so for the first one, we have x squared minus 6x is equal to 0. Now, this is a quadratic, okay, because we've got x squared. So the standard procedure is to try and factor the polynomial that's given. Once you can factor it, then you can find the individual solutions. Okay, so let's go ahead and try that. Okay, so this is 1.1.1. So we're given x squared minus 6x is equal to 0. Now, we call this standard form when all the x terms and constants are on the left-hand side and 0 is on the right-hand side. Okay, that's what we want. So what we need to do is try and factor this. Now, we see that between x squared and 6x, there's a common factor of x. So we can factor that out. So we have x into x minus 6 equal to 0. Now, once we have it at this form, we need to notice something. So if we have some number a times some number b is equal to 0, if we have something like this, then this means either a is equal to 0 or b is equal to 0. So one of them must be 0 for the product to be 0. So we can use that over here. We've got a product of two things being 0. So either the first thing must be 0, so x equals 0, or the second thing must be 0. So x minus 6 is 0. Now we can solve this really easily. X minus 6 is equal to 0. So x is equal to 6. And that gives us our two solutions. So typically when we have a quadratic, we're going to get two solutions. Okay, not always, but usually. Okay, like I said, if you have any questions while I'm going through, please just raise your hand and I can have a look. Okay, 1.1.2. So we've got another quadratic here. X squared plus 10x plus 8 is equal to 0. Now, let me just draw your attention to this part over here. Correct to 2 decimal places. Now, this is a big hint over here. Whenever they say correct to 2 decimal places, they're giving you a big hint that you cannot factor the polynomial. You know, like we did for 1.1.1, you can't do that here. Now, you know, even if you forget that, we can look at the polynomial and try to factor it. So we've got 8, which is our constant term. The factors of 8 are 1, 2, 4, and 8. However, none of those factors are going to get us to 10. So we know right away that's not going to work. Okay, so instead of trying to factor, we need to use the quadratic formula. Okay, so let's take a look. So, sorry, 1.1.2, we've got x squared plus 10x plus 8 is equal to 0. Now again, if we didn't get that big hint that we couldn't factor, you try to look at it, can't factor, so quadratic formula. So we need to recognize there's this invisible 1 over here, so that's going to be our A term, that's our B term, that's our C term. Okay, it's good to label things so you don't mix stuff up. Okay, so what is the quadratic formula? I'm sure all of you have it memorized by now. So it's going to be minus b plus or minus square root b squared minus 4ac all over 2a. Okay, now it's just plug in and solve. Okay, so we've got this plus and minus here, right? So we're going to have one solution with the plus, one solution with the minus. So let's plug in our values. Minus b, but b was 10. So it's going to be minus 10 plus or minus square root b squared, so that's 10 squared, minus 4a, but a is 1. We've got that invisible 1 there, times c is 8, all over 2a, but again, a is, we've got that 1 there. Okay, so we can simplify this. So this is going to be minus 10 plus or minus again. The square root, oops, sorry, 100 minus that, so we're going to get 68 over 2. Okay, so This is in what's called surd form. Okay, so let me just put a little star here. Whenever you got your square roots going on, that's surd form. The question specifically said correct to 2 decimal places. So we don't want surd form. So you're going to type this in your calculator and you're going to write out the answer to 2 decimal places. In other words, decimal form. So we're going to get 2 solutions from this, one with the plus, one with the minus. So we're going to get x is equal to minus 0.88 as a decimal, or the other solution, the one with the minus there, minus 9.12. Please remember 2 decimal places. And if you need to do any rounding, this is the part where you do that as well. Okay, so depending on how they ask it, please remember to write your solution that way. So if they ask for surd form, you leave it in surd form. If they ask it in decimal, please put it in decimal. Okay, let's go to the next one here. Okay, so for the next one, we've got an inequality. So we're trying to solve for x, but there's this inequality here. So we're not going to get a specific value for x. Instead, we are going to get some interval. So x is going to be less than something, x is going to be greater than something, or maybe between 2 values. But the idea is it's not a fixed value. Okay, so we've got 1 minus x, x plus 2 is less than 0. Okay, let's take a look at that. Okay, this is 1.1.3. We have 1 minus x, x plus 2 is less than 0. Okay, so what we're going to do is we are going to find the so-called critical values. So critical values, okay, fancy name, but all it is the solutions where it's equal to 0. Okay, so that's where this name critical comes from. It's where it actually equals 0. So we can just pretend it's equal to 0, and we're going to get our 2 critical values. So from the first bracket, we're going to get 1 minus x equals 0. The equals means the critical part. So here we're going to get x is equal to 1. That's our first critical value. Let's just make a note. Critical means equal to 0. Yeah. Our next bracket is x plus 2. And again, critical means equal to 0. So we're going to get x is equal to minus 2. Now, these aren't our solutions. They're only the critical values. It's like an intermediate step that we're going to use. Okay, so next, we need to draw our number line. So this is our x number line. And we're going to put our 2 critical values. So clearly, x equals minus 2. That's going to come first because it's negative. It's the smaller one. So we write x is equal to minus 2. 1 is going to come second. So we have x is equal to 1. Cool. We've got our 2 critical values. Now we need to draw in the parabola. Okay, so if you don't know if it's a happy face or sad face based on what's given, just multiply it out. So let's do that on the side. So we have 1 minus x, x plus 2. Okay, so just looking at this, we're not too sure if it's happy face or sad face. So let's multiply it out. So 1 times x, that's going to be x. 1 times 2, that's going to be 2. Minus x squared minus 2x. Okay, so you don't need to worry about simplifying because we know that the x squared term has a negative coefficient. Negative coefficient, well, that's a sad face parabola. So we've got ourselves a sad face parabola cutting through our 2 critical values. So what does that mean? Remember, this x line is like our x-axis. Anything below the x-axis is going to be negative. Anything above the x-axis, well, that's going to be positive. And again, anything below the x-axis, That's going to be negative again. So you see, we've broken this up into 3 regions, 2 negative regions, 1 positive region. Okay, let's just go back to see what we were looking for. Over here, we wanted less than 0. In other words, we are looking for the negative regions. So that's the first region and the third region. Okay, so how do we describe the first region? Well, that's everything before -2. So x is less than -2. Or, because we've got another region to take care of, it's everything after 1. So x is greater than 1. Now, just a quick little note here. Over here, we have strictly less than. So it can't be equal to 0. So if the question has strictly less than or strictly greater than, well, then our solution better have that as well. So that's strictly less than, strictly greater than. Okay, no equality there. Okay, I've got a question here. Is there a way to solve this without using graphs? Of course. So if you don't want to draw the graph, we can do this another way. Let's just scroll down here. So you still need to find the critical values. Okay, no matter what method you use, you have to do that. So let's just do that again. So we have our critical values. Those were x is equal to 1 and x equals -2. Okay, so we're going to do it without using graphs. So we just rewrite the expression we're interested in. 1 minus x, x plus 2. So 1 minus x, x plus 2. And we would like this to be less than 0. Okay, so what we do is we take a look at our 2 critical values. So x equals -2. The first thing we need to do is pick an x value that is smaller than -2. Oh, sorry. Sorry, less than 0. Okay, so what we need to do is choose something less than -2. Let's say -3. So if we sub in x equals -3, what do we get? We're going to get 1 minus -3 multiplied by -3 plus 2. Okay, so that's going to be 1 plus 3, that's 4, multiplied by -1. So this is a negative. So we see that everything before -2 gives us a negative answer. Or everything smaller, should I say. Gives negative. Okay, so that's our first clue as to what's happening. So everything smaller than x equals -2 gives a negative. We've shown that there. Next, we choose something between the critical values. So we have something between -2 and 1. Let's just choose 0. So if we choose 0, we're going to get 1 times 2. That's going to be a positive. So if we sub in x equals 0, so this is between our critical values, we're going to get 1 times 2. That's positive. Okay, so that's our first bit. Then we need to substitute something greater than 2, because that's our second, greater than 1. That's our next critical value. So let's substitute 2. So if we sub in 2, okay, we're going to get 1 minus 2, that's -1, times 4, that's -4. That's a negative. So if we sub in x equals 2, we get a negative. So everything after 1 is going to be negative as well. So everything greater than x equals 1 is negative. Okay, so what do we notice here? We saw that everything smaller than -2 gives a negative. Everything greater than 1 gives a negative. So that gives us our solution as well. Okay, so we have our solution. Everything smaller than x equals -2, so x is less than -2, or everything bigger than 1 is also negative, so x is greater than 1. I got another question here. Let me just take a look. Please use the straight line graph for me in this example. I'm not familiar with the straight line graph. Could you explain it? I'm not familiar with that method. Please, could you just explain it in the chat, and then my colleague will have a look at that. Okay, just while we're waiting for that, let's take a look at this next one. Okay, so for this next one here, 1.1.4, we have the square root of x plus 18 is equal to x minus 2. Okay, so immediately when you see the square root, you should be thinking there could be problems. Why? Because we cannot take the square root of a negative number. So that immediately causes problems for us. This x plus 18 underneath the square root can't be negative. That's not going to work for us. Okay, so let's be a bit careful with this one. Okay, so 1.1.4, we have the square root of x plus 18 is equal to x minus 2. Okay, so what we want to do is solve for x. However, we've got the square roots in the way. Okay, we don't want that. How do we get rid of square roots? We square. So we're going to square this side. We're going to square this side. However, big warning sign. Squaring causes problems. Okay, big warning sign there. Now, why does squaring cause problems? Well, because if the number was negative, if you square it, it's going to be positive. If the number was positive and you square it, it's going to be positive. So you see, you lose that information on whether it was positive or negative to begin with. So you need to be very careful when you are squaring things. You lose that information. Okay, so it's okay. You can still square the thing. That's perfectly fine. However, if you do square something, if you do get rid of that square root, check your solutions. Okay, because you might run into a problem. Okay, not always, but sometimes. So let's square it, but please keep these two things in mind. Okay, so the square root of x plus 18 squared, that's just going to be x plus 18. Equals. We're going to square this, so we're going to have x squared minus 4x plus 4. X squared minus 4x plus 4. Okay, now this is not in standard form. So what we want is all of the terms on one side, everything else, that's the 0 on the other side. Okay, so we've got the x squared on the right-hand side, so let's leave it there. So we're going to get x squared minus 4x minus x, so that's minus 5x, plus 4 minus 18, so that's minus 14. Cool, so we need to try and factor this. So we need factors of 14 that get us to 5. That's going to be 7 and 2. Okay, so we're going to end up with x minus 7, x plus 2. Because minus 7 plus 2 will get us back to our minus 5. Okay, so this is going to give us two solutions, as usual. We're going to have x minus 7 is equal to 0. So x is equal to 7. That's one possible solution. Or, I've got another bracket to check. X plus 2 is equal to 0, so x equals minus 2. Okay, but remember our warning sign. Check your solutions. So we need to check them. So let's check x equals 7. So how do we check a solution? We look at the left-hand side, we look at the right-hand side, and we see if they match. So left-hand side is going to be the square root of 7 plus 18. And then the right-hand side will be, we're substituting in 7, so it will be 7 minus 2. Okay, so the left-hand side is the square root of square root 25. Right-hand side, 7 minus 2, that's going to be 5. But the square root of 25, that's just going to be 5. Okay, so we've got a match. Okay, so the left-hand side equals the right-hand side, so that's good. So x equals 7, that's a valid solution. Okay, what about x equals minus 2? We need to check that as well. So left-hand side is equal to the square root of minus 2 plus 18. So that's the square root. Or we could have just said 18 minus 2. So it'll be square root of 16 equals 4. What about the right-hand side? Remember, the solution is minus 2. So we get minus 2 minus 2. Well, that's minus 4. We've got a problem there. So once the right-hand side is minus 4, the left-hand side is plus 4. That does not work. So remember what I said. When you square something, you lose the information about the sign. In this case, we see how that reflects here. One is positive, one is negative. That's not going to work. Okay, so we forget the solution. That's not going to work. So we only have one solution. Therefore, there is only one solution. Yeah, and that's the first one we check, x equals 7. Okay, so remember, whenever you have these square roots, we've got the square roots here. It's perfectly fine to square both sides. You can get rid of the square roots, but please remember these two warnings. Squaring causes problems, and remember to check your solutions. Okay. Cool. Let's have a look at the next one. So we want to solve simultaneously for x and y. So we've got two equations, a linear equation over here, x plus y equals 3, and we've got some quadratic in terms of x. Okay, so let's write these out and then solve simultaneously. Okay, so this is question 1.2. So we have x plus y is equal to 3. That was the first equation that's given. And then the second was 2x squared plus 4xy minus y is equal to 15. Let's call this equation 1. Let's call this equation 2. So what should we solve for in the first equation to substitute in the second? Now, if we solve for x, then we're going to be substituting into x squared. Okay, that's perfectly fine to do, but that could cause problems. If we solve for y, then we're only substituting into this 4xy and the minus y. Okay, so we're not too worried about the squaring over there. So from equation 1, let's solve for y. So we're going to get y is equal to 3 minus x. Okay, the other option is perfectly valid, but this is a bit safer to do. Okay, so let's substitute our new equation 1 into equation 2. So we're going to sub 1 into 2. Okay, let's see what we get. So we're going to have 2x squared plus 4xy, but we've got a new form of y. That's going to be 3 minus x. Minus y, but again, we've got a new form of y. That's 3 minus x. Okay, and all of this is equal to 15. Okay, so now we've got a new equation, a quadratic in terms of x, but the nice thing is it only contains x, which means we can solve for x, and then we can solve for y. So let's go ahead and do that. So we're going to have to expand this out first. So we're going to get 2x squared plus 12x minus 4x squared minus 3 plus x. And while we add it, let's take the 15 across. So minus 15 is equal to 0. Awesome. Now we've got some common terms that we can add together. We've got the 2x squared and we've got the minus 4x squared. We can put those two together. We've got the 12x and the x. We can put those two together. And we've got the minus 3 and the minus 15. We can put those two together. So we're going to end up with minus 2x squared plus 13x minus 18 is equal to 0. Okay, and we want to try and factor this. Okay, so we look at our A, we look at our B, and we try to see, given that product, so the product of 18 times 2, which factors would give us 13? Now we need a sum or difference to give us 13. Okay, so in this case, we should factor it as 2x minus 9 or x minus 2 is equal to 0. Okay, so let's just check. So that will give us 2x squared. Yep. So it'll be 2x squared minus 4x minus 9x. Yep, that gives us our plus 13. And then minus 9 times. Yep. Okay. Another thing, just a little note here. In the front, we've got a minus 2. So typically, we don't want negatives in front. So we could also write this as 2x squared minus 13x plus 18 is equal to 0. So if you prefer to have positive coefficients of x squared, you can go ahead and use that as well. Reason being is that the right-hand side is 0, so you can multiply by whatever you like. In this case, we just multiply by negative 1. And then we got this positive factor. Okay, so if you like to work with that, you can go ahead and do that as well. Okay, so now we've got this factor here. We can separate it out. So again, we've got the product of two things being 0. So for the first one, it's going to be 2x minus 9 is equal to 0. So 2x is equal to 9. So x is equal to 9 over 2. Okay. Let's just leave it as a fraction. Okay, it'll help us later. And then for the second one, we have x minus 2 is equal to 0. So x is equal to 2. Okay, so we got our 2x solutions. Now, you don't have to do this, but this is what I like to do. Label my solutions x1 and x2, just so we don't mix them up. So x1, that will correlate with y1. x2, well, that will be with y2. So we're not mixing up our things. So now that we've got x1, we can then find y1, because y1 will be 3 minus x1. So y1 will be 3 minus x1. Similarly for number 2, y2 will be 3 minus x2. Okay, so we're not mixing anything up by numbering them 1 and 2. Okay, so here we're going to have y1 is going to be 3 minus x1, but that's 9 over 2. Okay, we can write the 3 as 6 over 2. So that gives us minus 3 over 2. And then on the other side, y2 is 3 minus x2, but x2 is 2. So that's 3 minus 2. So y2 is going to be 1. Okay, so that gives us our solutions. Now, if you want to write them nicely together, you can write it as a coordinate if you want. So x1 will be 9 over 2, and the corresponding y1 will be minus 3 over 2. So that's like our solution 1 grouped together. And our solution 2 grouped together will be 2 and 1. Okay, so this is solution 1 and solution 2. Okay, are there any questions about this one? Okay, you're all good. Very happy. Ah, awesome. Glad to hear it. Next one. Okay, so when I saw this, it was pretty interesting. We want to find if n is the largest integer for which n to the 200 is less than 5 to the 300. Okay, determine the value of n. Okay, so this is pretty interesting. Let's have a look. Okay, so this is 1.3. If you're following along with the numbers, this is n to the 200 is less than 5 to the 300. And we want to find the biggest integer n. The biggest integer n. Emphasis on the integer. We want whole number solutions for this. Okay, so if you just look at this, it seems very daunting because you've got one exponent of 200, another exponent of 300. Now, how are we going to handle this? So what we can do is separate out the 100 from both of these factors. So we can write this as n to the 2 times 100 is less than 5 to the 3 times 100. Okay, so remember, if we have a product in the exponents, we can write this as a double exponent. So we can write this as n squared to the 100 is less than 5 cubed to the 100. Okay, because we can use a double exponent if we have a product of exponents like that. Now, a little note over here. Exponents preserve inequality. Well, not quite, provided we're working with integers, which we are, so that's fine. In other words, if 2 is less than 3, then 2 to the 100 will be less than 3 to the 100. Doesn't matter what the exponents are, the inequality is preserved. So we can just drop the exponents. So this is exactly the same as n squared is less than 5 cubed. Because the inequality is preserved, we can just drop the exponent. Provided the exponents are the same, of course. Right? So we've got this as 100, this as 100, so we're safe. Now, what is 5 cubed? So n squared is less than 125. Okay, so what we want is a square number, some square number that is immediately before 125. Okay, so we just go through our numbers. So 10 squared is 100, so we're getting close. 11 squared is 121, that's even closer. But 12 squared is 144, and we've gone too far. So it looks like 11 is our goal. So 121 is less than 125, but more importantly, 121 is 11 squared. And if we substitute a 12, so 12 squared equals 144, we've gone too far. Oh, someone's saying that they lost. Where did I lose you? What point did I lose you there? What happened to 100? Okay, let's go back and look at that. So the reason we can drop the 100 is because exponents preserve inequality. So if we take a look at this little example here, if we know that 2 is less than 3, and we know 2 is less than 3, then we also know that 2 to the 100 is less than 3 to the 100. Because you can raise both sides to whatever power you like, the inequality remains the same. So if we can go forwards, or we can also go backwards. So if 2 to the 100 is less than 3 to the 100, well, that automatically means that 2 is less than 3. So that's exactly what we've got here. We've got something to the 100 is less than something else to the 100. So if these two things are in this inequality, we can drop the 100 because it's still the same thing. Okay, so we can go both ways here. Okay, please just take a look at this mini example on the side. No, this is just exponent laws. This is nothing from grade 11. It's just exponents. Okay. Yeah, so it's just exponent laws. If you have 2 is less than 3, or you don't even need to the power 100. You can say if 2 is less than 3, then 2 squared is less than 3 squared. We're saying the same thing here. As long as you raise both sides to the same exponent, the inequality is the same. When else can we drop the exponents? Only in this case. Okay, so only when you have the same exponents on both sides, then you can drop it. Okay, like I said here, we've got 100 on this side. We've got 100 on this side. If it's the same on both sides, then you can drop it. If you have different exponents, you have to keep them. Okay. Someone's asking n is equal to, yeah, we're getting there here. So, like I said here, if we pick, so we're just going through the numbers, right? So we're looking for which integers will get us to 125. So if we pick 11, that's going to be 121. If we pick 12, that will be 144. But that's too much. That's bigger than what we wanted. Okay, so n is equal to 11.
Where does the 1 to 1 come?
Okay. Okay. I'm going to let my colleague answer those questions, just so that we can move along. Okay, so that's it for question 1. Let's take a look at question 2 now. So usually question 2, that's going to be your patterns. So your linear sequences, linear patterns, your quadratic, and so on. So question 2.1. We've got 7x, y, minus 11, and so on. And we're specifically told here that it's an arithmetic sequence. Okay, so it's a linear pattern, like your an plus b kind of thing. Common first difference, all of those keywords. Determine the values of x and y. Okay, so let's give that a go. Okay, so this is question 2.1. If you're following along with the numbers. So we've got this pattern 7x, y, minus 11, and so on. Okay, and we're specifically told this is an arithmetic sequence. Okay, so X and Y, those are missing. We want to know what they are. Okay, now there are several ways to do this. So let's go through them. So firstly, let's say that the common difference here is D. D for difference. So between X and 7, i.e. X minus 7 is going to be 9. Between X and Y, in other words, Y minus X, that's going to be D. Between minus 11 and Y, that's going to be D again. Okay, it's an arithmetic sequence, so we have a common first difference of D. Next, we have a starting term of 7. Okay, so let's keep that in mind. So if our starting term is 7, let's call that A. So we have A is equal to 7. Next, how many hops does it take to get from 7 to minus 11? We've got 1 hop to X, 2 hops to Y, 3 hops to minus 11. So what we have is that 7 plus 3 hops of D, 3 hops going along, is going to give us minus 11. Okay, we've hopped 3 times. We're now at minus 11. So we can solve for D. So 3D is going to be, so 3D will be, oh no, we can just leave that, sorry. D is going to then be minus 6. So we take the 7 across, divide by 3, we get minus 6. Okay, so we've got A, we've got D, so that means we've got our solution. Okay, so that's method number 1. What about method number 2? So let's rewrite our sequence, 7x, y, minus 11, dot, dot, dot. And again, since it's a arithmetic sequence, we have a common factor, sorry, not common factor, common first difference of D. In other words, you pick any 2 here, we take the difference, we're going to get D. Yeah, you're going to get negative. So we have 3D. Let's just write that here. 3D is going to be minus 11 minus 7. So that's going to be minus 18. So D is going to be minus 18 divided by 3. So that's minus 6. Okay, those are the working out of it. So for method number 2, we're going to do things a bit differently because we know that between any 2 terms, we're going to have the same common first difference. In other words, let's look at the first pair. X minus 7, that's our first difference. That's going to be equal to y minus x, because that's the first difference for the next 2 terms. And we can look at the next one as well. Y minus x, that difference will also be equal to minus 11 minus y. So what did we do? We looked at the first 2 and we got the first difference. We looked at the next 2, we got that difference. We looked at the next 2 and we got that difference. And all of them must be equal because we have a common first difference. Okay, so all of the first differences must be equal. Okay, so what do we have here? Let's simplify the first one and call it equation 1. X minus 7 is equal to y minus x. We can write this as 2x minus 7 is equal to y. We're just simplifying that. Our second equation that we've got, we can simplify that as well. So taking the y across, we're going to get 2y is equal to minus 11 plus x. Okay, so what do we got? We have 2 equations and 2 unknowns. Well, that's just a simultaneous equation. Yeah, so it's simultaneous. So we've got equation 1, we've got equation 2. We can then solve. So let's substitute number 1 into number 2. So sub equation 1 into equation 2. What are we going to get? We're going to get 2. Y has this form of 2x minus 7 is equal to minus 11 plus x. Okay, I've just subbed in y from equation 1 into equation 2. Okay, so let's multiply this out. So we're going to get 4x minus 14 is equal to minus 11 plus x. Okay, so let's bring the x terms together. So we're going to have 3x, if we take the x across, minus 11 plus 14, that's going to be 3. So x is equal to 1. Okay, that's good. We've got x is equal to 1, but what about y? Okay, so if x is equal to 1, that means y is equal to 2 times 1 minus 7. 2 minus 7, that's going to be minus 5. So we end up with x is equal to 1, y is equal to minus 5. Okay, exactly the same as if we look over here. Remember, d is minus 6. So we're going to have one hop of d to get to x, another hop to get to y. We can get the same solution. Okay. If you have any issues about this one, please post your questions in the chat. My colleague's going through all of them now. Okay. Let's take a look at the next one. Okay, so it's good to know several methods because during the exam situation, you might get stressed out and forget one method. It's good to have a backup method just in case. Okay. Just give me a second. Someone is drawing on the screen. Okay. So question 2.2.1. We're given this quadratic number pattern. So it's quadratic. We know it has some form. So it has some form. Tn is equal to an squared plus bn plus c. It's going to look like that. 2.2.1. Determine the general term of the pattern in the form Tn is equal to an squared plus bn plus c. In other words, find the pattern. Okay, I'd really appreciate it if you would stop drawing on the screen. Okay, so let's go ahead and answer this. Okay, please just give me a second. Okay, let's go through this. So we've got this quadratic pattern, minus 3, 6, 27, 60. We want to find the formula. Okay, that's a standard technique to do that. So 2.2.1, for those of you following with the numbers. So we have minus 3, 6, 27, 60, and so on. So how do we find the formula? We need to find the first difference, we need to find the second difference, and then we can find A, B, and C iteratively. So between minus 3 and 6, that's going to be a difference of 9. Between 6 and 27, that's going to be a difference of 21. Between 27 and 60, that's a difference of 33. Okay, so we've got our first differences now. Next, we need the second differences. So between 9 and 21, that's going to be a difference of 12. Between 21 and 33, that's a difference of 12 again. Look at that, common second difference. Perfect. So what we need to do now is identify this term, and this term. They will be used to find the pattern. So firstly, 2a is going to be equal to 12. So a is going to be equal to 6. Second, 3a plus b is equal to 9. So 3 times 6 plus b is equal to 9. Okay, so taking that across, we're going to get b is equal to minus 9. And lastly, a plus b plus c is equal to minus 3. We know a is 6. We know b is minus 9. We don't know c. We want to find that. Okay, so 6 minus 9, that's going to be minus 3. Cancel on both sides. C is going to be 0. So we've got A, we've got B, we've got C. Let's put it all together. So Tn is going to be an squared plus Bn plus C. So that's going to be 6n squared minus 9n. And then you can put the plus 0 for C, but you don't need to do that. Okay, if you have any issues with this one, please post your questions in the chat.
I think there's a mistake somewhere.
Okay, 2.2.2. Calculate the value of the 50th term of the pattern. Okay. So we've got the general formula for Tn. So finding the 50th term is really not that difficult. So T50 will be 6 times 50 squared minus 9 times 50. In other words, I'm just letting n be 50. Okay, so easy answer. Put in your calculator. We're going to get 14,550. Okay, so this is the 50th term. Okay, any issues with this? Okay, I don't see any. Oh, got a question. Okay, no, awesome. Let's take a look at the next one then. Two point 2.3. Show that the sum of the first differences. Okay, so we're not looking at the original pattern anymore. We're looking at the first differences. So that first pattern that we derived of this pattern can be given by Sn is equal to 6n squared plus 3n. We're looking at that part over there. So let's take a look at our first difference pattern and then take the sum of the first n terms. Okay. Okay, so let's take a look at our pattern again. So this top row was our original pattern. That was the quadratic. The second row is the first difference pattern. This is going to be linear. Okay, so we're interested in the sum of these terms, the 9, 21, 33 terms. Okay, so 2.2.2. Sorry, 2.2.4. Okay, let's just go back to the question here. Okay, so we're doing 2.2.3. Show that the sum of the first differences. So this is that second row I was talking about. So if we sum up the first n terms of our second row, we get this nice formula over here. Okay, this is the goal. Okay, we want to get to that. Sure, no problem. Okay, let's take a look. So again, let's take a look at the second row, 9, 21, 33. So that's our starting point. 9, 21, 33. And then, of course, this continues. Okay, that continues down. So we need to look at our first term. So A is equal to 9. That's our first term. Next, we need to look at the differences. So between 9 and 21, there's a jump there. Between 21 and 33, we have the same jump. So what are those jumps? We need 12 to get from 9 to 21. We need another 12 to get from 21 to 33. In this case, our jump D will then be 12. Yeah, and that's all the information that we need, because we know that there's that general formula for the sum of a linear sequence. Let's write it down. Sn, the sum of the first n terms, will be n over 2 into 2a plus n minus 1 d. We know what a is, we know what d is, so we're good to go. Sn is then going to be equal to n over 2. 2 times a, we've got that there, that's going to be 18, plus n minus 1. D, we've got that over there, that's going to be 12.
Nice.
Okay, a little bit more algebra and then we're done. So we're going to have 18 plus 12n minus 12. Okay, the 18 and the minus 12, we can put those together. We're left with the 12n. So Sn will be n over 2, 12n, and then 18 minus 12, that's going to give us 6. Cool, we've got common factors throughout. So Sn will then be equal to 6n squared. We're multiplying the n inside plus 3n. Okay. Are there any issues with this one? If there are, please let me know in the chat. Someone's lost. Where did I lose you? Sorry, someone's lost here. Where did I lose you? Last step. Why is it n over 2? Over here, from the formula.
It's from the formula. It's n over 2 from the formula.
Yeah, so where did I put that? Over here. There's the formula there. It's actually provided on your data sheets as well at the back. And as to where did it go? Well, 12 divided by 2 is 6, and 6 divided by 2 is 3.
Guys,
Okay. Someone's asking, where did 18 go? 18 minus 12, that's going to give us 6. Please take a look at the step over here. Okay, awesome. Everyone seems to be on the same page. Someone wanted to look at the question again, so let's just go back here. Here we go. That one over there. Okay, let's take a look at the next one. So how many consecutive first differences were added to the first term? Okay, let's break this down. So how many consecutive? So consecutive means one after the other. So, 1, 2, 3, 4, 5, those are consecutive. First differences, well, that's the second row that we derived at the beginning. Okay, we're added to the first term of the quadratic. That's going to be minus 3. to obtain a term in the quadratic number pattern with this value. So this is our Tn for the quadratic. Okay. So we're beginning with the first term of the quadratic. We are adding some number of consecutive first difference terms to arrive at this goal, our Tn goal. Okay, we want to know how many did we have to add. Okay, so let's take a look. Okay, so let's just rewrite the pattern so we can see it from before. So -3, 6, 27, 60. That was our pattern there. Remember what the first terms, the first difference terms were. That was 9, 21, 33, and so on. So the question is asking, if we begin with -3, so we begin with -3, we are going to add some number of first difference terms. So we're going to add 9 plus 21 plus 33 plus ... some number of first difference terms. And we want this to be equal to that goal number. Let's go back there. This goal number over here. We want that in the end. Okay, so this is going to be equal to 21060. Okay, this was the statements of the problem. You begin with the first term, you add some number of common first difference terms, and we end up with this. We want to know how many do we need to add. Okay, but what is this in brackets over here? This in brackets is just the sum of the terms. Well, we worked that out already. This is going to be -3 plus Sn, we worked that out, is equal to 21060. And we want n. Yeah, we want to solve for n. Okay, so let's substitute. So Sn, we calculated this before. That's going to be 6n squared plus 3n is equal to, we're going to have to take that 3 over. So it would be 21063. However, this is not in standard form, so it's not going to help us yet. We need to take everything over to one side. So we're going to get 6n squared plus 3n minus 21063 is equal to 0. Okay, so what we want to do is find this n. Okay, so how do we go about doing that? Well, first of all, we've got a common factor of 3 throughout, so we can get rid of that. So we're left with 2n squared plus n minus 7021. Okay, so that's just to simplify things a bit. Now, we can use the quadratic formula to find out our solutions. So n is going to be equal to -1 plus or minus the square root of 1 squared minus 4ac all over 2a. Okay, so we're going to get two solutions as usual. Our first solution will be n equals 59. Our second solution will be minus 119 over 2. However, minus 119 over 2 is certainly not a natural number. So this is not a solution.
Okay, so I'm lost. Where did you get 2n squared plus n is minus 721?
We took this previous step and we divided by 3.
Oh, okay.
Okay, so yeah, because we get the quadratic, we get 2 possible solutions. One is not a natural number, so that part goes away. We're left with n is equal to 59. So the answer is n is equal to 59. Okay, so that's how many terms we need to add. Okay, are there any issues with this? I've got a question here. Why did
No,
we
sir,
use
thank you.
-3? This -3 over here, that is the first term in our quadratic pattern. I've got another question here. Does this method work for all of these types of questions? Yes. Yeah, so this working out is very general. You can use it for other questions as well. Okay, if you have any further questions, please put it in the chat and my colleague will have a look. Okay, let's take a look back at our paper. Quick summary. Okay, sure. Let's go through that. Okay, someone wanted a quick summary of the question. So the question asked, if we begin with the first term of the quadratic number pattern, in that case, it was -3. The question asked, how many first difference terms do we need to add to get to some number? In other words, plus some number of first difference terms. Okay, so we have our starting term for the quadratic number pattern, the first term. We are going to add some number of first difference terms, and we want this to be equal to okay, and we want this to be equal to our specified number of 21060. This was given in the question, so we can just take that as given. So how do we rephrase this to work out what we want? So we can rephrase this as -3 plus some number of first difference terms. So what were our first difference terms? Those were 9, 21, 33, and so on. And we want this to be equal to 21060. However, the sum of the first n terms, we calculated that in the previous question. That was Sn from the previous question. So all we need to do is solve for n. Yeah, and that will give us our solution. But please remember, n has to be some natural number or positive integer. Can't have any fractions or negative numbers. Okay. Okay, if you have any questions, please just put that in the chat and we can have a look. Can you please show? Of course. Let me just find that. Here we go. Nope, not that one. Here we go. Okay, so let me just clear this. Okay, just give me a second. Someone's asking about the times here. Okay, so here we go. Session 1. Yeah, we are finishing at 11. Sorry, I've gone over time a bit. But if you would like me to carry on, that's perfectly fine as well. Okay, let me just look at the chat here. Sorry, I just want to look at the chats here. There were some questions there. Can you please repeat question 2.1? Okay, let me just have a look at that. Question 2.1. Okay, sure. Let me just go over that quickly, and then we can finish off with the session. Okay, unless you want to carry on, then that's fine as well.
Sorry, can you please do function?
Yeah, let's see. Yeah, we'll skip to the function section then. Let me just go over 2.1 again. Someone was asking for that. Okay, so let's go over 2.1 again. Okay, so we're given the following arithmetic sequence. So as soon as you hear that word arithmetic, you know it's going to be linear. Okay, so how did it go? It was 7x, y, minus 11, and so on. Okay, so we know it's linear, which means from 7 to x, there's some jump we can do, d for difference. Between x and y, there's another difference, d. Between y and minus 11, there's another difference, d. It's the same hops each time. So from 7 to x, how did we get to here? We added d. From x to y, we added d. From y to minus 11, we also add the same jump, d. So just by looking at this, we can see that the first term is 7. So let's write that down. First term equals 7. So that means our variable a must also be 7. Remember, a is the first term. Next, from 7 to minus 11, we took 3 hops. From 7 to x, from x to y, from y to minus 11, we did 3 hops. So 7 plus 3 hops. So let's just put that here, 3 hops. This needs to give us minus 11. Okay, because that's the term that we land on. We land on this term. Okay, so we just need to solve for d now. So 3d is equal to minus 11 minus 7. So 3d is going to be minus 18. So d is going to be minus 6. In other words, we make hops. We make hops of minus 6. Okay, so from 7 to x, we went down by minus 6. So that means x needs to be 1. From 1 to y, we go down by minus 6. So that means y is going to be minus 5. So let's write that out. 7, we need to go down by minus 6. So we reach 1. 1, we go down by minus 6. So we reach minus 5. Minus 5, we go down by minus 6. We get to minus 11. This term here was x. This term here was y. And that's how we get our 2 values. Okay, I hope that helps. 3 because of 3 hops. Yeah, exactly there. Okay. I see some of you want to continue. So let's go through the functions. I will go until 12. That should be enough time to go through the functions. And then we can carry on with the next section. Sorry, the next day, right? In the pamphlet. Okay, so let's take a look at the functions part.
Do you have any session tomorrow?
Oh, let's go back to here. Here we go. Here's the sessions. So we're looking at this first row under mathematics. So Friday the 29th, that's today. It says 11, but we're going to go through the functions now. Then Thursday, we're going to carry on. And then Saturday, the 6th of November, we'll carry on as well. So about halfway through session 2, we'll move on to paper.
Writing on the 5th of this month.
Okay, if you do have any queries, please put it in the chat and then my colleague will have a look. Okay, but these are the sessions as planned so far. Okay, so session 1, maybe half of session 2, there'll be paper 1. We should be done with that. Half of session 2 up to session 3, we should be done with paper 2.
I'm writing our math paper 1 on the 5th of November.
Sorry?
The problem is we're writing our maths paper on the 4th of November, so most of the things you wouldn't have done them by then.
Oh, it's on the 4th. Okay, okay. Okay, no, so we should be done with today. Functions is pretty much the only major part left to do. Okay, so let's take a look at the function questions. Over here. Okay, so first function question. We've got ourselves a hyperbola. So -3 over x minus 1 plus 2. So just looking at that, we should be able to identify the asymptotes. So let's just go through that quickly here. So if we look at the denominator, we have x minus 1. So when does the denominator become 0? When x is equal to 1. There's problems there when x is equal to 1. So that's going to be our first asymptote. X equals 1, there's going to be problems. Next asymptote. We see that we have shifted up by 2. So that means the y asymptote also goes up by 2. So these are our asymptotes. Okay, so there's the asymptotes, easy 2 marks. 4.1.2, determine the equation of the axis of symmetry that has the negative gradient. Okay, so we need to determine the equation of the axis of symmetry that has negative gradient. So how do we go about doing that? Okay, let's take a look here. Okay, so sorry, let's just go back to the question here so we can copy that down. Okay, so 4.1.2. Sorry, please just give me a second. Please, can we go over the asymptotes again? Sure. So let's look at this function. We see that in the denominator, we have x minus 1. So remember the asymptotes, the vertical asymptote is when the denominator is equal to 0. Okay, so let's make a little note there. Vertical asymptote is at the denominator being equal to 0. Okay, so in this case, this denominator is equal to 0 when x is equal to 1. And then the y asymptote is this value over here, this plus 2. So we see that the y asymptote is 2. Okay, those are our two asymptotes. Okay, so 4.1.2, determine the equation of the axis of symmetry that has negative gradients. Okay, so we want the downward sloping axis of symmetry. So let's go through that. This is 4.1.2. Okay, so remember the axis of symmetry, that those are straight lines, right? So we're going to have y equals mx plus c. It's a straight line. Okay, so what do we want? We want to find the axis of symmetry with negative slope. So what we can do, if we just go back here, we've got 2 points, x equals 1, y equals 2. That's that central point to the hyperbola. You know, the very center, that's x equals 1, y equals 2. So we can substitute that in. So x equals 1, y equals 2. And we want the negative slope, so m equals minus 1. That's all of our information. So 2 is equal to minus 1 plus c. So c is equal to 3. Okay, so that gives us our axis of symmetry. So y is equal to minus x plus 3. Okay, so this was for the negative axis of symmetry. You can do exactly the same thing for the positive axis of symmetry, but in that case, the gradient will be 1. So m equals plus 1 for positive axis of symmetry. Okay, but it's exactly the same procedure. You're just swapping minus 1 for plus 1.
Sir, can you please repeat what you just did?
Oh, sure, no problem. Okay, 4.1.2. We've got ourselves the hyperbola, and we want to find the negative axis of symmetry. Okay, so we know that the axis of symmetry is a straight line. So it's going to have the form y equals mx plus c. Okay, so that's the first thing we need to know. Second thing, since it's the negative axis of symmetry, we know that the gradient must be minus 1 because it's the negative axis. Number 3, we know that this line will pass through, so we know that this line will pass through our asymptotes that we had here. Let's go back here. This x equals 1, y equals 2. The axis of symmetry will pass through that point over there. Okay, so let's put all of this together. So we know that the gradient is minus 1. So we're left with y equals minus x plus c. And we also know that it passes through this point. So 2 is equal to minus 1 plus c. So we can solve for c. So c is equal to 3. So if we know m, we know c, we know the final formula. So y is equal to minus x plus 3. And then, of course, you can repeat the same procedure for the positive axis. So you can do the same thing for positive axis. But in this case, for the positive axis, we know that m is +1. Okay. Okay. If you have any further questions, please post them in the chat, and my colleague can have a look. Okay. Next question. Okay, so for the next one, we would like to sketch the graph showing the asymptotes and the intercepts with the axes. Okay, let's go ahead and do that. So we would like to sketch the graph of h. Okay, so let's write down the function first so we know what we're working with. So h of x is equal to, here we go, -3 over x minus 1 plus 2. -3 over x plus 1, sorry, minus 1 plus 2. Okay, so there's a couple of things that we need to notice. First, we've already found the asymptotes. So this is the vertical asymptote from there. This gives us our horizontal asymptote. Sorry, asymptote. Okay, so that's 2 bits of information. And we know that this numerator is -3. So it's going to be one of those negative hyperbole, you know, the ones like that. Okay, so we've got an idea of what to do. Let's do a quick sketch of our xy plane. So we've got x, we've got y. Where are our asymptotes? X equals 1, that's one of them. Y equals 2, that's another one. Okay, and now we can fill in what the function looks like. So it's going to be in the second quadrant and the fourth quadrant with respect to these asymptote lines. So it's going to look something like that and something like that. Okay, so that's just a rough sketch. However, we do need to find these 2 intercepts over here. Okay, so we still need to find the x-intercept and y-intercept. Yeah, so we still need to find those. Let's start off with the x-intercept. So the x-intercept, what does it mean to be an x-intercept? It means the y value is 0. So what happens if the y value is 0? We're going to have 0 is equal to -3 over x minus 1 plus 2. Okay, and we want to solve for x. So let's take the -2 across. So the positive 2, we take it across, it becomes -2. So that's going to be -3 over x minus 1. Okay, we can divide through by -3. So we're going to have 2/3 is equal to 1 over x minus 1. We can take the reciprocal, both sides. So 3 over 2 is equal to x minus 1. So x is going to be equal to 5 over 2. So this gives us our x-intercept 5 over 2 and 0. Because we previously defined y to be 0. Okay, so that's the first bit done, the x-intercept. Next, we need to find the y-intercept. So let's go through that. Y-intercept. What does it mean to be a y-intercept? It means the x is 0. So if x is 0, then what are we looking for? We're looking for h of 0. So it's going to be minus 3 over 0 minus 1. So minus 3 over 0 minus 1 plus 2. Okay, so we have minus 3 over minus 1. So that's just going to give us 3 plus 2. That's going to give us 5. But that's only half the work. It's going to be 0, 5. I've got a question here. Couldn't you multiply the denominator on the x-intercept? So for the x-intercept, you wanted to multiply the denominator. That's perfectly fine. Yeah, you can do that as well. You can take that across and then solve for x. Okay, but you know, it's up to you. Whatever you need to do to solve for x. Okay. Any other questions? Okay. My colleague will handle any questions. Yeah? You got a question there?
How do you get the coordinates?
Okay, so over here, this was y equals. So our first part was x is 0. And here we were solving for y, and we got y is equal to 5. So x is 0, y is 5. Same thing with this one. X is 5 over 2, and y is 0.
Okay.
Okay, someone's asking, please, can you redo 4.1.2? Okay, sure. That was the axis of symmetry. Okay, let's take a look at that.
Can we do financial and probability?
Okay, sure. Let's just get through the functions work first. So 4.1.2, that was finding the negative axis of symmetry. Okay, so we want to find the negative axis of symmetry. So first of all, we know that the axis of symmetry is going to be a straight line. So it's going to have the form y is equal to mx plus c. Okay, because it's a straight line. Number 2, we want to find the negative axis of symmetry. So the negative axis, that means that our gradient is going to be minus 1. Number 3, the line will pass through, the line will pass through the intersection of our asymptotes. Okay, remember that the axes of symmetry pass through the intersection of the asymptotes. What were the asymptotes? They were x equals 1 and y equals 2. So it has to pass through this line, through this point. So let's put 1, 2, and 3 all together. So we know that the gradient is minus 1. And we know that it passes through this point. So that means y is equal to 2 and x is equal to 1. We take the minus 1 across. We're going to get 3 is equal to c. So we back substitute into there. We get y is equal to minus x plus 3. And of course, the same procedure works for positive axis as well. Okay, no problem. Happy to help. Okay, let's take a look at the next function question. Okay, so we're done with that. Let's move on here. Okay, so we've got ourselves a parabola f and a straight line g. So A is the turning point of f. Okay, that's at the bottom there. The axis of symmetry of f intersects the x-axis at E. Okay, we've got that there. And it intersects our straight line at D. Okay. Next, C is the y-intercept of f and g. Okay, that's very important. Let's put that down. They share a y-intercept. Okay, and we can see on this other side, they also share an x-intercept. Okay, so they share a y-intercept and they share one of the x-intercepts. Okay, so let's take a look at the questions here. 4.2.1, write down the coordinates of A. So A is the turning point of the parabola. Now, the nice thing is the function f is written in the turning point form. So we know immediately what our turning point is. Yeah. So we've shifted to the left. So that means the turning point has negative x value. Okay. Next, write down the range of f. So f is our parabola. We see that the smallest y value is over here. And the largest y value, well, it doesn't have a largest y value. It goes off to infinity. So that means, sorry, I made a mistake there, -8. So that means that the range will go from this lowest value of -8 up to infinity. In other words, y is greater than or equal to -8. Okay. 4.2.3, calculate the values of m and n. So m and n is this intersection here. Now, we know what that x line is. This x line is x is equal to -5. Okay, because it has the same x value as our turning point. Okay, so that x line is -5. So immediately we know that m is equal to -5. Okay, because anything along that line shares the same x value.
I'm sorry,
Okay, what
sir.
about n? Yes.
Sir, can you just say for 4.2.2 is y are elements of real numbers?
Yeah, that's right as well. Yeah. Well, we
Thank
kind of
you.
assume that it's real numbers, but you can say that as well. Okay, but this is the important part, saying that it's greater than or equal to -8. That's where the mark is. Okay. Okay, so we've got m. Now we want to find n. N is the y value of that point. Okay, so what we can do is we can take our straight line and we just substitute m. We take our straight line, we plug in m, we're going to get n. So what is that going to be? That's going to be g of -5. So g of -5, we can just plug that in there. That's going to be -5/2 plus 9/2. So 9 minus 5, that's going to be 4 divided by 2, that's 2. Okay, so we've got m is equal to -5 and n is equal to 2. Okay, so those are the two values that we found. Next, calculate the area of OCDE. Okay, so we've got OCDE. Oh, let's fill that in here. Let's just fill that in here so we can see what it looks like. Okay, it's that portion over there. So from O up to C, down to D, down to E, and then back to O. Okay, so that highlighted region, we want to find that area. Okay, so it's a trapezium, right? So we've got the two vertical lines are parallel. So let's just fill that in there. Those are parallel. So we've got ourselves a trapezium. So we want to work out the area of a trapezium. So let's go ahead and do that. So OCDE is a trapezium. Okay, that's good to know because we can find the area as 1/2 of the length DE plus OC. Okay, so 1/2 of that times OE. Okay, so where did I get these from? Let's take a look back here. Here we go. DE, that's one of our vertical parallel lines. OC, that's the other vertical parallel line. And then OE, that's our base. Okay, so that's where you get those values from. Okay, so let's substitute what we know and get our answer. So this is going to be 1/2. DE, that's going to be 2. OC, that's going to be 4.5. And OE, that's going to be 5. How do we get these numbers? Let's go back here. Okay, we know the value of E, so we can find the length OE. We know the value of C, okay, so we can work out that value, and we know the value of D. We know that height, so we know the height D, we know the height C, we know the base. We've got everything we need. Okay, so this is going to be equal to, taking that, we're going to get 16,25, 16.25. Or if you don't want to write it as a decimal, we can keep it as 65/4. Okay, if there's any questions about this, please just let me know in the chat and we can take a look.
Sir?
Yes?
Can I ask? Okay, I get it, that's a trapezium. Now, I wanted to know if I can break the trapezium into a rectangle and a triangle and then first find the area of a triangle, then find the area of the rectangle, then add up those two areas.
Of course, you can do that as well. And there's no problem with that. So let's just take a note here. You could break up the trapezium
Second, okay.
Into a rectangle and a triangle. Of course, there's no harm in doing that.
Sir, could you please repeat 4.2.3?
4.23. That was finding the values of M and N.
Yes, can you please repeat?
Yep, sure. Okay, someone just mentioned on the chat here, yes, since we're finding an area, you should write units squared. Okay. Because it's some area value. Okay, so you want to go over 4.2.3. Sure, let's do that. Okay, so for 4.2.3, we know that D has the coordinates mn. We want to find those values. So let's take a look at that picture. We see that our picture here, we've got D. D lies on this vertical line, x equals -5. So that means the x value of D will be -5. So that's our first bit of knowledge. So since D lies on the line, x equals -5, we have m is equal to -5. So that's the first thing. Now we need to find the value of n. How do we go about doing that? N is the y value of D. But D also lies on the line G, on that straight line. So let's put that down. 2. Since D lies on the line G, we have n is equal to g of m. Okay, because it's on the straight line, so it must satisfy this equation. So we just need to plug in the value m is equal to -5, and we can solve for n. So n is equal to g of -5. So that's going to be 1/2 of -5 plus 9/2. That was g. So this is going to be -5/2 plus 9/2. So that will be 4/2, and that will be 2. Okay, so we've got n is equal to 2. So m is equal to -5. N is equal to 2. Okay, I hope that helps. I've got a question here. How do you find the maximum length of a line between two graphs? Okay, good question. Let's take a look at that. Finding the maximum length between two graphs. Okay, so let's just take this graph as an example. So we've got the following setup. Let's just see what that looks like again. We've got this parabola and the straight line. Okay, so we've got a parabola, something like that, and we've got the straight line, something like that. Okay, so to find the distance between the two functions, we want this distance over here, that vertical line. So let's say the top one is f and the bottom one is g. So what is the distance going to be? The distance will be equal to the upper function f minus the lower function g. Okay, so just remember upper minus lower. Okay, so since we've got a straight line and a parabola, this distance function will be a quadratic. So it will be quadratic. In other words, it will be a parabola. Okay, so we've got the distance function, and we know that it's going to be a quadratic or a parabola. So all we need to do is find the maximum. In other words, the y value of the turning point. And then we're done. So if you want to find the maximum distance, all you need to do is find the maximum of this distance function. Now, this distance function will be a quadratic or a parabola. So to find the maximum, we just need to find the y value of the turning point. And the way that you do that is you complete the square. Okay. So if you complete the square, that will give you the turning point. You just look at the y value of the turning point, and that will give you your maximum value. Okay. Let's go back to our functions questions. Okay, next, 4.2.5. Determine the equation of G inverse. Okay, so we've got our function G, that's the straight line. We want to find its inverse. Okay, let's do that. Okay, so G of X is equal to 1/2 X plus 9/2. We want G inverse. So what we do is instead of writing G of X equals that, we write it Y is equal to 1/2 X plus 9/2. Then we perform a swap of variables. So X and Y, they get swapped. So we rewrite this as X is equal to 1/2 Y plus 9/2. We then solve for Y. Okay, so how do we solve for Y? We need to take the 9/2 across. So that's going to be X minus 9/2 is equal to 1/2 Y. We want to solve for Y, so let's multiply through by 2. So Y is equal to 2X minus 9. Okay, but we can't leave it like that. We need to write Y is equal to G inverse. Okay, so after doing the swap, this new Y expression will then be our inverse. And we can write this as the inverse of G. Okay, and remember this little minus in the exponent here, that means inverse. Okay, so this is the standard procedure for finding the inverse. So we write the expression in terms of Y.
X and Y equal, or are they swapped?
Sorry? Oh, over here.
For the inverse, you swap X and Y, or are they equal?
Yeah, we swapped them.
Okay, so if
So
you
we
say
swap
they're
X
equal,
and
you're
Y.
wrong.
Sorry?
If you say X is equal to Y, that means you're wrong.
Yeah, no, they're not equal. So X is definitely not equal to Y. Okay, so we are swapping them. We are definitely not making them equal. Okay, if you have any further questions, please just put them in the chat. Okay, 4.2.6. If h of x is equal to g inverse, okay, so we just found g inverse, plus k is tangent to f. Determine the coordinates of the point of contact. So we know that this new line, h, is tangent. So h is tangent at some point xy. We want to find that point. Okay, so we've got this new function h. It's tangent to f at some point. We want to know where is it tangent. Okay, so let's go through this.
Is it this?
So finding point of contact. Okay, so let's start off by writing out f, because that's the function we're interested in. So f of x is equal to 1/2 x plus 5 squared minus 8. Okay, so remember, to find the tangent, we need to find the derivative. So we need to first expand this out so we can do the deriving. So f of x is going to be equal to 1/2. Let's expand this out quick. X squared plus 10x plus 25. And then don't forget that minus 8 there. So if we just write this out again, f of x is equal to, I'm going to distribute the half. So it's going to be 1/2 x squared plus 5x, and then plus 25 over 2, but then we're minusing 8. So that's going to be plus 4.5. Okay, so we've got this function, but we need the derivative because we want to find that tangent line. So f prime of x will then be x plus 5. Okay, we ignore this constant here. That goes away. So we've got the derivative. It gives us the gradient at x. Okay, so that gives us the gradient at x there. Okay, so what was the tangent line? Remember, it was given as h of x was g inverse plus k. So that's going to be 2x minus 9 plus k. This was the tangent line. Okay, so now that we have that, we can solve for x and y. So x plus 5 must then be equal to 2. Because this is the gradient at x. This is the gradient, 2. So we make the gradients equal. So that means x is equal to 2 minus 5. That's minus 3. Okay, and if x is equal to minus 3, then that means y is going to be minus 6. Just substituting back into our function there. Sorry, minus 6, not minus 3. Okay, sure. Let me repeat that. So we have x is equal to minus 3. This is the contact point. Contact point on the function f. Okay, so that's the x value. So if we want to find the y value, we just use f of x. That gives us the y value. Okay, because it's the same contact point. So if x equals minus 3 is the x part of the contact point, then f of x will be the y part of the contact point. And we've got f up here. So we can just substitute minus 3 into this expression, and we're going to get minus 6. So the contact point is minus 3, minus 6. Okay, awesome. So we've got the contact point. Please note, this comes up a lot as a very silly mistake. This expression here, this is not the tangent line. This f prime of x, it is not the tangent line, it is the gradient at x. It's this m value over here, our gradient. Okay, definitely not the tangent line. Okay, please don't make that mistake. Okay. Someone's asking, where did you get -6? That's over here. F of x is equal to y. So y is equal to f of -3. So if we go back to our thing here, 1/2 x plus 5 squared minus 8. So it will be 1/2 -3 plus 5 squared minus 8. So that will be -3 plus 5. That's going to give us 2 squared. That's 4 divided by 2 is 2. 2 minus 8. Oops, sorry. Jumping ahead. 2 minus 8. That's -6. Okay, you just plug your x value into the function, and that will give you the y value. Okay, I hope that helps. Okay, so we've got 3 minutes left. So please, if you do have any other questions, please will you post them in the chat now, and then we can have a quick look through that. If you have any longer questions, please can you send those through on that email address? Okay, and then we can take a look and send you solutions. Okay, so let's just go back to this page here. Okay, here we go. Oops, sorry. There we go. This is the next session, session 2. That's going to be Thursday, the 4th of November from 9 to 11. Okay, and of course, if you do want extra time, I'm fine with that as well. Okay, but just for now, if you have any questions, please put them in the chat. We can have a look at those. Short questions, please. If you have any longer questions, please send them through to that email address. Okay, thank you, everyone.
Thank you so much.
No problem at all. Happy to help.
Thanks. Thanks.
Thank you. Okay, thank you guys for attending. Dalia Varghese put up a link to a register and survey. Please, if you guys can complete that, we would love your feedback on what we can do better. And we'd also like to know what we've done well. And we'd also like to record your attendance. Thank you for attending.
Thank you.
Can we have another session? Sorry.
Sorry?
Yes, I was asking if can we have another session tomorrow.
Yeah, I think the tomorrow.
Yes.
So from the that we circulated, the next math section is on the 4th. So that's the day before your paper, am I right?
Yes.
And I think the following one is on the 6th. And so your next paper too, I think, is on that Monday, the 8th. So am I correct in saying that? So that was how the sessions were set up. But I'll tell you what you can do. If you have any questions, I mean, tomorrow you can, or even today, you can send them to the email address that's on the advertisement that's been circulated on the chat as well. And the same tutors will respond to you one-on-one. We'll do our best to get back to you one-on-one as soon as possible. And we also have a website that's been set up. And what I'll do is additional sessions if we set them up, okay? But as for now, there's no session set up for tomorrow.
Okay. Okay, thank you.
No problem.
Part of the UKZN experience is the opportunity to be part of a community and to network with not only our world-renowned academics, but with future game changers and leaders. They do say that the extent of one's success can be attributed to those they rub shoulders with. Therefore, you must surround yourself with like-minded people. So, how do you become part of a community that is committed to your self-development? How do you become part of UKZN? First, you have to apply. All applications for undergraduate studies at UKZN are processed through the Central Applications Office, CAO. This is for both your course and student residence application. The application process is as follows. Step 1. Consult the CAO handbook. This handbook provides a list of all qualifications available at UKZN. Step 2. Have a look through the various courses offered and choose a program that interests you and for which you meet the minimum requirements. As one of the top 5 universities in the country, UKZN promotes academic excellence. So meeting the minimum requirements does not guarantee you a place to study. Step 3. Find the program code linked to your chosen qualification. This is the code you need to enter in your application form. Okay, let me show you something. You see, a code has 3 parts. Example, for BCom in accounting, the code is KN-P-BCN or KN-W-BCN. Crazy code, right? Well, basically, the KN stands for UKZN, the middle part stands for the campus of your choice, P for Pietermaritzburg, W for Westville. Then BCN stands for the actual course. Make sure to get these codes right. Step 4. Use this program code when completing your CAO form, which is available from the CAO website. Your application will be sent to UKZN. You can always check the status of your application using your CAO number, ID number, or passport number on this website, www.caocheck.ukzn.ac.za. For more information, visit www.cao.ac.za. It's that easy. Pay close attention to closing dates for qualifications.
I knew we were
For
only going to get
example,
to the first bit.
MBCHB closes on the 30th
Because
of
they
June,
always say
while
B
other
for B,
undergraduate programs close on the 30th of September. What are you waiting for? Apply now and shape your future today.
So thank you everybody for attending today's sessions. I've posted the next upcoming sessions in the chat. It's chemistry and then physics. And please remember to provide your feedback for today's session. If you don't have any questions, you may please leave the session. You can log off.